Hello everyone, welcome to the presentation on monitoring solution for RDS custom for SQL Server using Amazon CloudWatch. In this presentation, we will be discussing briefly about the RDS custom for SQL Server and the monitoring tool. We will explore how this combination of the SQL Server instance and the monitoring tool can help you gain a better visibility on the RDS custom instance. And at the same time, you can monitor the performance metrics and troubleshoot any issues that might come after. I am Arnab Saha, a Senior Database Specialist Partner Solutions Architect at AWS. I work with AWS partners to provide technical guidance and assistance, thus enabling them to build a highly scalable and a secure solution in the cloud. Along with me, I have my colleagues Sid Joshi and Nanda Chinappa. Sid and Nanda, can you introduce yourself?
Hi, I'm Sid Joshi. I'm a Solutions Architect working on the Mid-Atlantic team in the US. My job is to act as a technical advisor for my customers and find solutions for their use cases. My specialization is observability.
Hello everyone, my name is Nanda Chinappa and I am a Cloud Infrastructure Architect at AWS Professional Services. My area of expertise are infrastructure automation, cloud migration and databases. I assist AWS customers in adopting the AWS cloud and achieving the desired business outcome by implementing cloud computing initiatives. Today's agenda includes discussing RDS custom for SQL Server and its various use cases for customers. Following that, we will provide a solution overview which outlines the utilization of CloudWatch metrics to monitor RDS custom for SQL Server. We will explore the CloudWatch metrics that are automatically generated as part of the solution. Additionally, Arnab will present an overview of the implementation steps, including the custom scripts we developed. We will conclude with a demonstration on how to download, install, and implement this tool in a customer's environment. We have successfully implemented this monitoring solution in multiple customer environments, resulting in their high satisfaction. So let's get started. Amazon RDS Custom is a managed database service for commercial database engines such as Oracle and SQL Server. It combines the advantage of a managed database service, including automated provisioning, backup, point-in-time recovery, and automation with the added capability for a database administrator to access and customize the database environment and the operating system. With RDS Custom for SQL Server, customers now have the flexibility to bring their own media and patches, allowing them to apply those specific patches. Additionally, unlike RDS SQL Server, which restricts database admin privileges and operating system access, RDS Custom for SQL Server grants customers sysadmin and admin privileges similar to what they would have on an on-premise SQL Server database. Now, let's take a look at the use cases of RDS Custom for SQL Server. Granular control. By having operating system access, you gain the ability to install custom drivers, enable specific features, or work with the application that require elevated level of access. Lift and shift business applications. There are two notable examples, Microsoft SharePoint and Microsoft Dynamics. Both of these applications require the installation of libraries at the operating system level for the database instance to function properly. Disaster recovery. RDS Custom for SQL Server provides capabilities to set up DR from a self-managed environment, allowing you to implement measures to protect your database in case of unexpected events or system failures. In AWS, you have multiple options for running SQL Server databases. You can choose to deploy them on EC2, which offers a self-managed approach. Alternatively, you can opt for RDS SQL Server, a fully managed database service provided by AWS. With RDS SQL Server, AWS takes care of essential tasks such as patching, scaling, backups, high availability, and disaster recovery, allowing you and your team to focus on business and application level responsibilities, giving you a competitive edge. Now, there is an additional option available for running your SQL Server databases with RDS Custom. As shown on screen, RDS Custom bridges the gap between running databases on EC2 and RDS. Our primary recommendation for your workload is to choose RDS if you seek a fully managed database experience. In this offering, AWS fully manages both the databases and the operating system. However, we understand that some customers have applications that require administrative rights to the database or underlying system while still deciding a managed database service. For such use cases, RDS Custom proves to be the ideal choice. With RDS Custom, customers retain complete access to resources and have the flexibility to make any necessary changes or customizations that might impact seamless automation. To address this challenge, RDS Custom incorporates additional safeguards to support automation. With RDS Custom, there's a shared responsibility between customers and RDS for tasks like backups and patching. With Amazon RDS Custom for SQL Server, you can now customize your database server and operating system. You can apply special patches or modify database software settings to accommodate third-party application that requires privileged access. Now, I will hand it over to Arnab, who will walk you through the solution overview, the list of CloudWatch metrics that we are monitoring as part of the solution, and the high-level implementation steps. Arnab, over to you.
Thank you, Nanda. Let's deep dive into this monitoring solution. So this is an overview of the solution. As mentioned earlier, in RDS Custom for SQL Server, we have access to the underlying host. As a part of this solution, we collect the host level metrics using a script and publish them to a custom namespace in Amazon CloudWatch. These metrics include the server metrics, the database metrics, and volume metrics, which are obtained from the Windows Performance Monitor tool. These metrics are then displayed on a custom dashboard within Amazon CloudWatch. Customers do have the ability to configure CloudWatch alarms and receive email alerts through Amazon's simple notification service. Now let's look at the metric that will be displayed on the CloudWatch dashboard for our customers through this script. Under Infrastructure Metrics, you can monitor the following. The free storage space. This metric allows you to track the available storage space within the RDS Custom for SQL Server instance. CPU utilization. This metric provides insight into the usage of the CPU resources within the instance. Available memory. This particular metric indicates the amount of memory that is currently available for use within the instance. In RDS Custom for SQL Server instances, there are two volumes. The root volume, which contains the installed operating system, and the data volumes, which store the SQL Server database related files. If any of these volumes become full, the RDS Custom for SQL Server instance enters a storage full state. Therefore, we have included individual monitoring metric for each of these volumes to ensure their storage levels are monitored accurately. In terms of workload metrics, we have incorporated the read and the write IOPS along with the read and write throughput. These metrics will provide the customers with the ability to monitor the performance of their SQL Server workloads. Additionally, under workload metrics, customer can also observe the database connections metric and the buffer cache hit ratio. From a performance metrics perspective, we have included the average read and the write latency metric and the average queue length metrics as a part of this solution. In this particular slide, I will explain the scripts that we are using in the backend, which will cater to this monitoring solution. So allow me to explain the purpose and functioning of this script in the backend. So we are adding three scripts. The first one called CloudWatch Agent Config Automation.ps, which serves as a wrapper script which is responsible for automating the installation process. It updates the two scripts mentioned below and finalizes the installation. The second script is CloudWatch Agent.json, which gathers information such as memory usage, TCP connections, and logical connections. It publishes this data in a custom CloudWatch namespace. The third script, dashboard config.json, is a configuration file for the dashboard. It retrieves the raw data from AWS/EC2 and AWS/EBS and the custom namespace. Then it performs mathematical calculations to present the required CloudWatch metrics on the CloudWatch dashboard. In this slide, we are showing the deployment of the script which automates the entire installation process. The script will ask the name of the custom CloudWatch dashboard as an user input. It is always recommended to provide the name of the RDS custom for SQL Server instance as the name of the dashboard. So in case if you got multiple RDS custom for SQL Server instance in your account or in that region, then you can differentiate all the dashboard based on the instance names. The script will automatically collect the EC2 instance ID, the instance AMI ID, the region, the volume ID, and the volume name attached to the RDS custom for SQL Server environment. The script executes in a minute and it deploys the dashboard in your AWS CloudWatch console. We will see this in action shortly. So these are the high-level steps for installing this monitoring solution. First, you need to have a RDS custom for SQL Server environment in your AWS account. Next, you need to download the script from GitHub and transfer the script in the EC2 host for the RDS custom for SQL Server instance. Then you use the installer to deploy the monitoring solution. Post-installation, you can view the dashboard in AWS console and also create CloudWatch alarms on the required metrics. This monitoring solution is available for download from GitHub, and we also have an AWS blog which explains in details about the solution and the metric which are monitored via this tool. Now, I will invite Nanda to show a demo of the installation of this tool, and you can see it in action how easily you can deploy the monitoring solution for RDS custom for SQL Server. Over to you, Nanda.
Thanks, Arnab. In this demo, I will walk you through the prerequisites that are required to be completed before the automation script could be executed. Once the prerequisites are met, I will proceed with executing the automation script. This script is designed to configure the CloudWatch agent on the RDS custom database instance, allowing it to capture the specific metrics from Windows Perform. Subsequently, the script will push these metrics to the custom dashboard, which is also deployed through the automation script. Now, let's get started. Here are the few prerequisites that are required for the automation script to be successfully executed. Install the AWS CLI, download the CloudWatch agent.json, dashboard.config.json, and CloudWatch agent config automation.ps1 file from the GitHub repo to the C drive. Ensure the EC2 instance role attached to the RDS custom database instance has the AWS CloudWatch put dashboard and AWS EC2 describe volume to get the required information for the automation script to successfully be executed. I have also copied the automation scripts from GitHub repo to the C drive of the RDS custom instance. You can find these scripts on the AWS GitHub repo. Now, let's install the AWS CLI. I have the installer copied to the RDS custom instance. Click on Next. Accept the terms in license agreement. Next. The AWS CLI has been successfully installed. I have ensured that I have AWS CloudWatch put dashboard and AWS EC2 describe volume permissions attached to the EC2 instance role associated with the RDS custom instance. Now that we have met all the prerequisites, let me give you an overview of the scripts that we will be using to capture the desired metrics and create a custom dashboard. CloudWatch agent.json. This script is used to configure the CloudWatch agent to capture the desired counters from Windows Perform and push the metrics to a custom CloudWatch namespace. In this script, we are capturing SQL Server General Statistics, SQL Server Buffer Manager, and Logical Disk. You can refer Microsoft Windows Puffmon public documentation for available counters and add any desired counters to this script. Next is the dashboard config.json script. This script is used to create the custom CloudWatch dashboard for monitoring RDS custom metrics that was captured and stored on the custom namespace by the CloudWatch agent. In this script, we provide the custom namespace information, metric name, instance ID, and all the information required to build the custom dashboard. If you are configuring the CloudWatch agent to capture a specific Puffmon counter, we need to add the metric information on this dashboard config.json script for the metric to be available on the custom dashboard. The last script is the automation script, CloudWatch agent config automation.ps1. This script uses EC2 metadata to capture the EC2 instance information like EC2 instance ID, AMI ID, region, and uses AWS CLI to capture EBS volume information and also create the custom CloudWatch dashboard. This automation script takes care of configuring the CloudWatch agent, updating the dashboard config.json script, and creating the CloudWatch dashboard. The only input to this script is the CloudWatch dashboard name. Now that we have reviewed all the scripts, let's create the custom CloudWatch dashboard by executing the automation script. To execute the automation script, open PowerShell as administrator, navigate to the C drive where you have saved the automation script, and execute the CloudWatch agent config automation.ps1 script. Provide the dashboard name. We can see that the script is performing the configuration of CloudWatch agent and creation of the dashboard. The configuration of CloudWatch agent and creation of dashboard has successfully completed. It might take few minutes for the CloudWatch metrics to populate on the AWS CloudWatch console. We can confirm the dashboard creation by logging into the Amazon CloudWatch console. We can navigate to metrics and see the custom namespace for your RDS instance created by the automation script. Now we can check the CloudWatch dashboard. Here we can see the custom CloudWatch dashboard that we created using the automation script. We can see the RDS custom metrics we captured using the CloudWatch agent being displayed here. You can also create CloudWatch alarm for any of these metrics to alert you if any of the metrics has met the configured threshold. You can refer the AWS blog post on Monitor Amazon RDS Custom for SQL Server using Amazon CloudWatch for the steps to create the CloudWatch alarm. I hope this video was helpful. Thanks for watching.
Thank you for attending this session. We hope you found the insights shared about RDS custom monitoring tool both informative and applicable for your specific use cases. If you have any further questions or need assistance in implementing this monitoring tool, please feel free to reach out to our team. We are here to support you every step of the way. Once again, thank you for being a part of this presentation, and we look forward for continued collaboration in the future. As always, happy cloud computing.